Today we would be explaining to you about the Pythagorean theorem, and we would give you examples your to make your understanding clearer. So about the Pythagorean theorem, this is the hypotenuse, which is the longest side from the triangle. Um, Plus, you will know if this is the hypotenuse because it is always opposite to the right angle. Uh, it's always a squared plus b squared equals c squared, which is the hypotenuse.
So we must always take in mind that the Pythagorean theorem only applies to right angle triangles, which means it won't apply to the equilateral, isosceles, or scalene.
We will show you visually on how this works. So first, remember that this only works for right angled triangles.
So as you can see from our earlier proof, if you didn't get it, you can pause the video and go back. So it's almost identical with our other proof, or the one we're supposed to explain. The only thing that's different is it lacks two triangles, somewhere about here and somewhere here. But the reason I didn't put it inside because I don't think it's effective or it doesn't make any sense to me. I read the website and I saw the triangles inside also, but there was no explanation on how to get it. It only was able to explain how to get the rest without the triangles, the irrelevant triangles inside. So as you can see, this here is a right angle triangle, and if you flip it, it will make this and so on and so on. So this one makes a giant square, and inside makes a quadrilateral.
We already labeled everything, and we labeled the big square K, L, F, M, and N. And right after that, we labeled the inner square, which is the hypotenuse. So we wrote C, C, and so on. So after that, you continue labeling the other parts. So A and B, and so on.
Finally, gonna relate it, or we're gonna explain how's it related and proves this is one of the proofs of the Pythagorean theorem. So we're gonna get the area of the small square. It can be easily written as c squared because side times the side of a square is the area. So c times c is equal to c squared. But we can also write that as c squared, the area of this, equals ab times a plus b. We're doing this because we're getting the area of the bigger square, and later we're gonna subtract it, but with the four triangles. So we'll only get this one. So that's ab plus ab times ab plus ab, these ones, and then we're gonna subtract 4 over 1/2 AB because there are 4 triangles, and to get the area of the triangle, it's base times height divided by 2. So that's 4 triangles, base times height divided by 2. And then when we're gonna simplify, we're gonna get a squared plus 2ab plus b squared minus 4 over 2ab equals 2ab. And then we can just cancel out 2ab and 2ab. So we'll be left with c squared equals a squared plus b squared, thus proving that the Pythagorean theorem works.
For example problem. Pedro wanted to know if a diagonal line drawn across a blackboard is longer than the horizontal line. He asked a teacher, but she said she only knew the measurements, which was 4 meters horizontally and width of 2 meters. Solve for the diagonal length. So you can make this a right angled triangle, and the solution is c squared equals a squared plus b squared. So c squared equals 4 squared plus 2 squared, and if you square them both, it's 16 plus 4. And If you add them together, it's c squared equals 20. Square root of c squared equals square root of 20. Equals c equals 2 square root of 5 smaller